What we are covering today is triangle similarity. So I will direct you to the first problem, number 3, on the first page of this review packet. Let's take a look. So if I take a look at two triangles and I tell you that they're similar, then what should be true about their angles? Should be the same. If they're similar triangles, they should have the same angles. First off, what does similar mean? Same shape. Same shape. Same shape. So if two triangles are similar, then they're the same shape, not necessarily the same size. So if they're the same shape, the angles should be the same. So let's take a look at this. I have two angles. How do I find the third? I've got two angles of each one of these triangles, 48, 65, 65, 67. It's not clear that they have the same angles because I don't know what the third angle is in each one of them. So I could, good, add them up and subtract it from 180. So 48 plus 65 is 113. 180 minus 113 is 67. So this angle here is 67 degrees. Do the same thing for this one. 65 plus 67 is 132. 180 minus 132 is 48 degrees. And lo and behold, there you go. 48, 65, 67, 48, 65, and 67. Cool. So the angles are the same, therefore I know that these two triangles are the same. But the reality is, if I had just been given 65 and 67, 65 and 67 for both triangles, then those triangles are similar. I don't have to find the third angle. Why? If two are equal, then the third has to be equal. They both have to add up to 180. Since they both have to add up to the same thing, that third angle has to be the same. So in order to show that two triangles are similar, all I have to show is that two sets of angles are congruent. Does that make sense? Yep. Okay. So let's continue. Take a look at number 7. Now, number 7, I want to modify the problem a little bit. So go ahead on your packet. Just write 12 here as if it had been given to you. Okay, so I just want to modify that problem just a little bit. So write 12 there as if it had been given to you. Now, if I know that two triangles are similar, what do I know about the corresponding sides? They're the same ratio. Very good. They're proportionate. What does that mean? Well, corresponding sides are like this side corresponds to this side, that side corresponds to that side corresponds to that side. So the ratios are the same between the two. Okay? So let's take a look. How do we solve for AC? Well, what I do is I set up the ratios. I say AC over its corresponding side, 12, equals, I have to find another set of corresponding sides. Well, that's 7.5 and 15. 7.5 over 15. You see? AC over 12 equals 7.5 over 15. How did I choose which one goes on top here, though? I know I want to put AC on top because that's what I'm solving for, so it makes my algebra easier if it's on top. But how do I know that I put 7.5 on top? How do we know that?
It comes from the same side as AC. So
it comes from the same triangle as AC. You're welcome. Very good. I have to stay consistent. If my triangle on the left is on top, AC, then my triangle on the left stays on top, 7.5. See that? Got to stay consistent. AC, 7.5. Both of them are on top. Okay. Any questions on that? Okay. So, Once I've set up the ratios, all I have to do is do the algebra to solve. I multiply both sides by 12, and I get AC equals, if I multiply it all out, I get 6. You will have your calculator for the whole exam. Make sure you bring a calculator. I'm not going to be there. I doubt the proctors are going to allow you to just, oh, can I just go run and borrow a calculator from somebody? I mean, they might. I don't know how that's going to go, but it's probably not the best way to start your final exam. So make sure you bring a calculator. And make sure if you borrow a calculator from someone, the first time you use that calculator is not while you're taking the exam. Okay? Because I'm not going to be there to show you how to use it. You got to make sure you know how. All right, next one. Number 8. Let's take a look. Here it looks a little bit more challenging because instead of two triangles right next to each other, you have one triangle inside of another. But if you look at it, it's quite clear that you have this smaller triangle and the larger triangle. Now, I'm trying to find AD. Question is, how do I find that? Well, here's AD. So I'll put that on top. But it'll be AD over what? 5. Good. And it's 5 because, look, the side on the left corresponds to the side on the left. Okay? Equals, now what goes on top? Would it be 9 or 12? It's 12. Why is it 12? Yes, AD comes from the bigger triangle and 12 comes from the bigger triangle. So I have to stay consistent and then multiply by 5. And I get 6.6 repeating. And I'm done. Any questions on that? All right, so moving forward, we're going to skip that next page and go straight to these ones here. Oh, sorry, not those ones. These ones here. Number 2, yeah, on less than 17.3. Numbers 2 and 3. Okay, let's take a look. So it's the third page, so I just skipped a page. We'll get back to it. It says, use similar triangles to find the lengths, the height. Okay, this is just about as easy as it can get. All right, you take a look, you find the corresponding sides. Well, this side corresponds to this side, so it's h over 6. You always put the quantity you're trying to find on top, and then stay consistent equals 60 over 15. You then multiply both sides by 6. You get h equals 60 times 6 over 15 is 24. Now, sometimes people will ask me things like, oh, don't I multiply 15 times 6 as well? The answer is no, because this is equivalent to 60 over 15 times 6 over 1. So it's just 60 times 6 over 15. The 15 doesn't get multiplied. So go ahead and do number 3 now. Do number 3 in your own. Okay, let's take a look. H over 5.5 equals 156 over 16.5. Multiply both sides by 5.5. Did you guys get the answer yet? What'd you get? 52. Good. Any questions on that one? All right. So moving forward, we go to these problems here, 6, 7, and 8. Mind you, all these problems are taken directly from your homework. So, if you want extra practice, there's tons of practice in your book. Now, we have these 3 problems here. Now, the first thing I want to do is figure out if these triangles are indeed similar. So I notice I've got one set of congruent angles there. What do I know about these angles here? They're vertical. And what do I know about vertical angles? They're congruent. Good. Okay, so I'm going to highlight my third angle. Now the only trick here is figuring out which sides are truly corresponding. And so how do I do that? Well, I do that by looking at the angles. So the side between the red and the blue corresponds to the side between the red and the blue angles. The side between the blue and the green corresponds to the side between the blue and the green. And finally, the side between the red and the green angles corresponds to the side between the red and the green angles. If you guys want to bring colored pencils and mark up the whole test and color it in and just, help yourself out that way, go for it. All right, once I have that, it's quite clear to see. It's D over 80 equals, staying consistent, 48 over 60. Multiply both sides by 80, and I get 48 times 80 divided by 60 is 64. Okay, any questions? All right, go ahead and do number 7 on your own. All right. So once you've done a couple of these, it's easy to see which sides correspond. D over 180 equals 78 over 45. Multiply both sides by 180. And I get D equals, thank you, 312. Good. I'm not going to do number 8. It's the exact same. So you guys can do that on your own. Any questions on these? All right. Now, let's take a look at this one, number 10. You guys ever seen a dinosaur skeleton before?
Yeah.
You have? Where did you see it? New York?
Yeah.
Museum of Natural History? Yeah, that's a cool place. You see the whale? Giant whale. You don't remember? It's pretty cool. But yeah, right? Pretty cool. You see these dinosaurs and you're just like, what? How? Imagine like a dinosaur just like chasing you. Be rough. Like seriously, we think life is hard. I've never had a Tyrannosaurus Rex chasing me. Like life is not that hard.
You didn't hurt him. You didn't hurt him. Skylar.
Did it hurt? Okay. All right. So we see a pretty ingenious way here of measuring the height of something. I'll give you just a visual image of this. So here's a person, right? there's the T-Rex or whatever standing in the distance. He puts a mirror on the ground facing up so that when he looks down into the mirror, he sees exactly the top of the Tyrannosaurus Rex's head in the mirror. Does that make sense? And because you can see that these two are right angles and these two angles will be similar because light bounces off at the same angle, right? These are two similar triangles, and then you can use that to measure the height. So that's pretty cool. It's a pretty cool way to measure the height of something. Now, I know these are similar triangles, but it's 5 feet 6 inches, 4 feet, and 40 feet. Before I just plow right into this problem, what should I do? What should I do? Change it all to inches. Good. Yes, I got to get them all to similar units. So I multiply by 12, 48, 480. 5 times 12 is 60. 60 plus 6 is 66. So that's all that in inches. And then once I've got that, it's simple. H over 66 equals 480 over 48. Multiply both sides by 66. And I get H equals 660 inches. Now, once I've got that in inches, I'm good. Technically, that's the right answer. What if I wanted it in feet? What would I have to do? Divide by 12. Good. So H is 660 over 12 feet, or 55 feet. And you're done. Any questions on that? Okay. Good. Now, we return to the pages that I skipped, or the page that I skipped rather. 17.1 Triangle Proportionality Theorem. Now, what does Triangle Proportionality Theorem tell us? Well, Triangle Proportionality Theorem tells us that if I have a triangle and it's intersected by a line that's parallel to one of the sides, okay? So this line intersects a triangle and it's parallel to this side, then it divides the sides proportionally. What does that mean? The ratio of this, 4 to this, 6, equals the ratio of this, KL, to this, 8. So 4 to 6 equals KL to 8. Simple as that. Okay? It divides those sides proportionally. So let me show it to you in a more visual way. If I highlight this segment and that segment in green, and this segment and this segment in blue, then green over blue equals green over blue. Okay? So 4 over 6, or I'm looking for KL, so KL over 8 equals 4 over 6. Multiply both sides by 8, and they get KL equals 5.3. Repeating. Okay? That's what Triangle Proportionality Theorem tells us. Now this next one, again, we have a line parallel to one of the sides. So it divides those two sides that it intersects proportionally. And we end up with green over blue equals green over blue. I'm looking for xz, which is this one, but I don't have xy. I have that the whole thing is 30, this is 18. How do I get xy? Yeah, let's just subtract. 30 minus 18 is 12. Once I've got that, it's simple. Xz over 30 equals 12 over 18. I multiply both sides by 30 to solve, and I get xz equals 20. Any questions on that one? All right, number 5, do it on your own. pretty great. Since I teach 4 classes of integrated math, by the time I get to you guys, I'm pretty efficient at doing it.
The recordings of some classes are so funny.
What?
Some of the people in some of your other classes, like when you're
When you listen to the recording?
oh my gosh, it's so funny. Like
No.
James Fry's in the back, like, hey, I like desks. I like sitting. It's just, I don't know. I was like watching last night.
Yeah, I remember that class. That's funny. Yeah, no, some of the stuff that comes out, I think some of my favorites though is like, this might sound bad or wrong, but some of my favorites is when I have to like crack down on a student in class. Sometimes it's happened to you guys, so sorry. But like when I have to crack down on a student, it's like, listen guys, you need to be quiet and pay attention and have respect. And that's like on YouTube forever. It's just like rough. That's rough.
All you do is
No, every day. Shh.
yeah.
Shh. In fact, I got evaluated one time. You guys know Mr. Wilson? Mr. Wilson, you guys know him? He's the middle school principal. He came into he came into one of my classes to just observe me. Like they do that. The administration does that to just they do it to like give pointers and to see what they observe, all that kind of stuff. It's not like a crazy thing, but anyway, one of the things that he wrote down was like and he kept good control of the classroom. Shh. He actually wrote that out. So, yeah. I tried my best. All right, so let's take a look. Again, we have a line parallel.
Was that all on recording?
Yes. All right. So again, we don't have this side, so we subtract. 49 minus 14 is 35. We're trying to find Vm, so it's Vm over 8 equals 35 over 14. Multiply both sides by 8. And I get Vm equals 20.
So I kind of set it up wrong, but I still got the right answer.
Yeah. You did Vm over 35 equals 8 over 14?
Yeah.
Yeah, that's fine.
Yeah.
It's technically the same thing. Green over blue equals green over blue, or guess what, guys? Green over green equals blue over blue.
Yeah.
It's just rearranging the same exact equation.
What can I say?
Okay. Math works that way sometimes. It's great. All right. Now, let's take a look. These ones, 6, 7, 8, basically is saying the same thing. You guys can work through them if you want, but we're not going to do them in class. Number 11. Okay, so it says you're given a map, 5th, 6th, and 7th Avenue are parallel. What's the length of Main Street between 5th and 6th Avenue? So again, we've got this situation where we have a triangle being divided by a parallel line, or a line parallel to one of its sides. So we get green over blue equals green over blue. This segment is what they're interested in. So x over 0.4 equals 0.3 over 0.5. So in this case, I'm doing blue over green equals blue over green. It's the same thing. And I do that just because I want to keep the term that I'm solving for on top. I multiply by 0.4. I get x equals 0.24. And I'm done. It's interesting when you see someone walking on the roof.
What was it?
Mr. Morgan, making an observation.
Mr. Morgan's always like in the windows.
Yes, go ahead. This might not be the best time to use the bathroom, though. We have one more page. All right, last page. 17.4. All right. Find the geometric mean of each pair of numbers. If necessary, give the answer in simplest radical form. All right. Geometric mean. If I have two numbers, A and B, what's the geometric mean of those two? How do I find it?
Over B.
No. No.
Oh, I forgot to do this.
I wasn't here for this lesson.
Square root of
A and B.
Plus B. Oh.
A times B. Find the geometric mean for the numbers in 4 and in 5. Go ahead. Do it now. Geometric mean is the square root of the product. Okay. In this case, geometric mean is the square root of 5 times 20, the square root of 100, which is 10. In this case, square root of 3 times 12, which is the square root of 36, which is 6. And you're done. Okay? Geometric mean. Now, this is the kind of question that it's like, if you know how to do this, how easy is that? Especially when you have a calculator, right? But if you don't know, there's going to be no hint. I'll just say, what's the geometric mean of these two numbers? And you better believe all the things that you might put, if you don't know what you're doing, will be answer choices. So like just the regular average, like 5 plus 20 over 2, or just like anything that you could probably think of that it might be, it's going to be on there. So you actually are going to have to know what you're doing, even though it's still multiple choice. So I'm sorry, but that must be. All right. Last thing. You guys ready? Here we go. Now, number 11, rather. Now, I have to explain this problem. I have a triangle, and I drop what's called an altitude. An altitude is a line segment that goes from a vertex and meets the opposite side at a right angle. See that? So that is an altitude. Well, the length of the altitude, you see how this altitude splits this side into two line segments, 30 and 40? The length of the altitude is the geometric mean of the two line segments. So in other words, x equals the square root 30 times 40, which is the square root of 1200. Did I not take roll today? Which equals 34.64.
I don't think you're going to get fired.
Hello?
Hey, don't joke about that.
She is not.
Oh, thank you.
I thought I took roll. Maybe I did. I don't think I did. Mrs. Pyle is very gracious to me. Thank God for that.
Stop.
Oh, I haven't taken what? I took roll last
I'm
time.
talking about you.
Who else isn't here? Carolina's not here. Marley. Charlie was here. Okay. All right. So x is equal to 34.64. You guys got that?
Yeah.
All right. Now, shh. See, there it comes out. All right. So this is 34.64. The question is, how do I find y and z? How do I find y and z? I know that I've got two right triangles, yeah? Very good. Pythagorean Theorem. Remember, it's the Pythagorean Theorem says a squared plus b squared equals c squared. Which one is c? The hypotenuse, which is opposite the right angle. That's important to remember. So in this case, I get 30 squared plus 34.64 squared equals y squared. 30 squared is 900. 34.64 squared is 1200 equals y squared. Add them together. 2100 equals y squared. What do I do now? Square root both sides. I end up with y equals the square root of 2100, or 45.83. Okay, everybody find z now on your own. Go ahead. Go ahead and find z on your own.
You do it.
Okay. So it's basically the same exact thing. I get 40 squared plus 34.64 squared equals z squared. 40 squared is 1600. 34.64 squared is 1200 equals z squared. Add them up. I get 2800 equals z squared. Square root both sides. I get z equals square root 2800, which is 52.92. I'm done. Does that make sense? Any questions? Yeah. Now, this is it, but I want to just direct your attention to number 10 real quick to take a look at something. Okay? So, let's take a look at number 10. This one's a little bit different. Who could tell me, I'm not going to do this one, I'll leave you to do it. Who could tell me how to get y?
You do 25 squared plus y squared equals 65.
Very good. Pythagorean Theorem. 25 squared plus y squared equals 65 squared. 65 is the hypotenuse. Now, once I have y, now I can say that y is the geometric mean of 25 and x. So this number, whatever it is, equals the square root of 25 times x. And I can use that equation to solve for x because it's the only variable that's left. Once I solve for x, I'll have x and y. Pythagorean theorem will solve for z. Does that make sense?
Yeah.
I'm not going over it because I'm not so focused on that type of problem. But if you want to be very well prepared for those types of questions, I would do it. Make sure you understand it. Any questions on any of this? All right, so we've finished quite early. You still have about 10 minutes left. What I would suggest is that you guys get a head start on the rest of this packet. My suggestion is for your studies is that you go forth and you look through these questions that I went over, do the ones, any that I didn't do, and definitely if you didn't understand any of it, go to that lesson in the textbook or watch my videos on YouTube for those lessons. Okay? Did I mention to you, real quick, look, lesson 16.4, lesson 6, look, if you look, there's these bold headings, and it tells you the lesson is from. Lesson 16.4, lesson 17.1, 17.3, so you can refer to those videos, but now once it gets to trigonometry, it stops saying lessons because we didn't go out of the book for there. It just says right triangle trigonometry, law of cosines, law of sines, and all that kind of stuff. So you can utilize those headings. Now, really quick, attention just for another 12 seconds. Listen, if I were you, how I'd study is I'd go back and make sure I understood everything I covered today, and then I'd continue on with the packet and try and get ahead. So when you're in class and I'm reviewing, you've already done the easy stuff, and it's just the hard stuff that you haven't done, so you can focus more specifically on that. Is that clear? All right. So if I were you, I'd take this time right now and use it to your advantage and get to work. Thank you for your attention.